So one of the things that I want to talk to you about is the antiderivative of 1 over x, or x to the power of -1. In the beginning of learning about antiderivatives or integrals, some students get confused about taking the integral or antiderivative of 1 over x dx. So suppose I want to take the antiderivative, let's say integral of 1 over x dx, which is the same thing as saying integral of x to the -1 dx. And the confusion comes usually from the fact that they forget that 1 over x or x to the -1 is not a polynomial. So you cannot use the power rule in reverse. So what I want to do in this video is to, first of all, remind you that the derivative of, in Math 151, or first part of the calculus, the differential part of calculus, we learned that d dx of natural log of x is 1 over x. And so, and also remind you that integrals and, or I should say derivatives and antiderivatives are inverse of each other. They undo each other. What do I mean by that? Suppose if you have that f of x equal x squared plus 1. So you know that d dx of, and if you want to take x prime, so f prime of x equals 2x. So we know that d dx of x squared plus 1 equals 2x. And in Math 152, or the second part of the calculus, the integration part, we learned that if you have, let's say, you want to take the integral of 2x dx, okay, that equals, so let me just, here's my 2, add 1 to this power, so I have 2, divide this by 2, this cancels out, and then you get, and I have a plus c in here. So the antiderivative of x, 2x, is x squared plus c. Notice that how here, if you take the derivative, and you get 2x, and if you take the antiderivative or integral of 2x, you go back where you started. So remembering that fact, and if you remember that the derivative of natural log of x was 1 over x, then it is going to be easy for you to remember that the antiderivative of 1 over x, or x to the power of -1, is natural log of x. And actually say, because of the domain issue, I should say that natural log of absolute value of x, and of course, plus c. So let's do, a couple of things. I don't want to just be content with just telling you this in a quick manner. Let's do actually a proof in here. Let's indirectly prove that the antiderivative of x to the -1 is natural log of x, a natural log of absolute value of x plus c. And when I say indirectly, because if I prove to you that the derivative of natural log of x is 1 over x, then I have proved to you that going back in reverse is taking the antiderivative of 1 over x, you get the natural log of x back. In order for me to do that, I need to remind you of two things. So first of all, remember that the definition of derivative is f prime of x for, by the definition, is limit as h is approaching 0 f of x plus h minus f of x all over h. So that's one thing I wanted to remind you. And the other thing that I want to remind you is the definition of e. The number e, one definition is that as limit as x is approaching infinity, 1 plus 1 over x to the power of x is definition of e. Or e equals this time limit as x goes to 0, 1 plus x to the power of 1 over x. These two have the same value. They're essentially the same thing. And why do I say that? Why do I say that these two are essentially the same thing? Let me go to the next page. So notice that when I have e equals limit as x is approaching infinity, 1 plus 1 over x to the power of x, if I let u, sum u to equal 1 over x, then x equals 1 over u. Okay, and so if I use e equal limit as 1 over u goes to infinity. So instead of using this x equals infinity, I'm using its equivalent, 1 over u equals to infinity, tends to infinity. So 1 plus u to the power of 1 over u. And so notice here, u must be going to 0. This u must be tending to 0. That's the only way that 1 over u tends to infinity. Keep that in mind. So I'm going to say, so limit as 1 over u tends to infinity. This is the same as saying u tends to 0. 1 plus u to the power of 1 over u. Okay. And so I'm going to use this last part for part of the proof that I need, at least the way I know how to, this proof is done. There may be other ways of proving it, but this is the way I learned it. And that was a very long time ago. All right. So here I want to say that prove that dx of natural log of x equals 1 over x. And I claim that I prove this, then I have proved that the antiderivative of 1 over x is natural log of x. So I'm going to go ahead and use the idea of limits and say that dx of natural log of x equals limit as h tends to 0, natural log of x plus h minus natural log of x all over h. Okay. So the next step, I'm going to use the laws of logarithm here for this numerator. And I'm going to rewrite this equal limit as h goes to 0, natural log of x plus h over x, using laws of logarithm, all over h. And now I'm going to simplify it one more step in here and say this equals limit as h is tending to 0. I'm going to rewrite the numerator as natural log of x over, let's see, x over x is just 1. And then h over x, okay. And instead of writing this h in here, actually I can do it next step, pulling 1 over h out. Let me go ahead and show all the steps there is. So now I'm going to rewrite this as limit as h is tending to 0, pull the 1 over h out, natural log of 1 plus h over x. Okay, that looks good now. And now I'm going to go ahead and put this using laws of logarithm and put this on the power. So I'm going to write limit as h approaches 0, natural log of 1 plus h over x to the power of 1 over h. And now things start, looking promising to me. Here, I'm going to go ahead and make a substitution. I'm going to say let sum n equals h over x. So then I can claim that h equals n times x, and h equals n. We said that was n times x, and 1 over h. Let's say that. Let me write here. And 1 over h equals 1 over nx. So 1 over h, and since I apologize, this was a 1 in here. So here I have 1 over h. My handwriting, this is h, this one is n. So 1 over h in blue, better be careful with my handwriting, 1 over h equal 1 over n times 1 over x. I should have chosen different alphabets, so that's okay though. So notice that here, as h equals to 0, n is going to 0. So we know that as h is tending to 0, n is tending to 0. And so limit as n approaches 0, natural log of 1 plus n to the power of, we had 1 over h, but I can rewrite that as 1 over n times 1 over x. Okay, so far so good. And now one more step, let's rewrite this as limit as n is approaching 0, natural log of, rewrite this as 1 plus n to the power of 1 over n. And let me use another parenthesis in here, to the power of 1 over x. So far, I didn't break any algebraic rules. And now I can bring this 1 over x, out. Going to the next page. Now this equals limit as n is approaching 0, 1 over x, natural log of 1 plus n to the power of 1 over n. And listen, I can take this totally out, okay? Limit over natural log, or limit over log, is log over limit. So using the laws of limits, I'm going to take the 1 over x out and write this as limit as n approaches 0, natural log of 1 plus n to the power of 1 over n. Okay. And so I know that by definition, we just showed that this was my E limit. Actually, let me do one more step and rewrite this as 1 over x natural log of limit of as n approaches 0, 1 plus n to the power of 1 over n. And notice, goodness, this is, by definition, this is E. We just showed it in the very beginning. So now I'm going to have this equals to 1 over x natural log of e. Well, what's natural log? Natural log is log base e. So natural log of e, this is just 1, okay? And 1 times 1 over x is 1 over x. So we know for sure that, we have proved indirectly, well, we have proved directly that derivative of natural log of x is 1 over x, which indirectly we just showed that the antiderivative of 1 over x, or x to the negative 1, is natural log of x. But since we are running in the domain issue, that, let me go to the next page. If you are taking the derivative of x to the negative 1, or 1 over x dx, this equals natural log of absolute value of x plus some constant c. Okay, email me if you have any questions. Thank you.